What's up, Bobcats? Mr. Peterson. Today, our awesomeness comes from curve fitting with quadratic models. You know you wanted to learn it. Now you get to. Your learning goal today should be to be able to use quadratic functions to model data and analyze and make predictions about that data. So basically, in a nutshell, what we're going to try to do is look at information and draw a conclusion about whether it's going to fit the models that we've seen for quadratics. Like, in other words, would its graph be a parabola, that kind of thing. So when we do that, the first thing we want to look at is we want to look at the second differences. When we have a linear situation, you should remember that when you look at the first differences, if they're always constant, you've got a linear situation. Well, with a quadratic, it's not the first differences, it's the second differences. We subtract our x terms, our y terms, excuse me, and if there's a constant differences in the second y terms, then we wind up with a quadratic data. And it's also important to note that your x values must be equally spaced. So let's try one or two of them. All right, so let's look here. The change, so we have equally spaced x values. So the change from here to here is -2. The change from here to here is -1. The change from here to here is 0. The change from here to here is +1. All right, so now let's look at our second differences. Okay, the change from here to here is +1. The change from here to here is +1. The change from here to here is +1. So yes, this example A is quadratic. I never realized how fun that was to say. All right, let's look at example B here. All right, so we have a set of first differences of here we went up by 1, so +1, then we went +2, then we went +4, then we went +8. All right, let's look at our second differences. From here to here we went up 1, from here to here we went up 2, from here to here we went up 4. So since our second differences were not constant, this is not quadratic. All right, so why don't you guys try this one? Tell me if that's quadratic. And this one, tell me if that's quadratic. All right, now this is the big mama problem of today. It's going to be a little bit of work, so get those pencils ready. You should recall from in Algebra 1 and in our conversations this year that if you have 2 points, that makes a line. So if you have 3 points, that makes a quadratic function. So we can find the coefficients of our quadratic function, a, b, and c, by using the x values from each point that we have, if we have 3 points. So this is kind of complicated. We want to pay close attention, take really good notes here. All right, I'm going to move this stuff out of the way because this is going to take a little work. All right, write a quadratic function that fits into the points 0, 5, 2, 1, and 3, 2. All right, so first up, let's look at our information. We have the point 0, 5. And we want to put that into our standard form of a quadratic, so that would be a times x squared, but here x is 0. So a times 0 squared plus b times 0 plus c equals, and that's usually y, or our output value, which in this case is 5. So we do a little work here. We get, this would become a 0, this would become a 0, and then c is all by itself. So we get c equals 5. All right, we want to box that. That's an important part to later in the problem. C equals 5. All right, now this is where it gets a little bit more challenging. But we're going to do the same thing with the other two. So we're going to take 2, 1, and we're going to plug it in as well. So that would be a times 2 squared plus b times 2 plus c, which we know is 5, equals equals 1. So what we have now is 2 squared. That would be 4a plus 2b plus 5 equals 1. And take away 5 from both sides. 4a plus 2b equals negative 4. Okay, we're going to do the same thing with the last order pair, which is 3, 2. 3, comma 2. So a times 3 squared plus b times 3 plus c, which we already know is 5, equals 2 in this case. So that's 3 squared is 9, 9a plus 3b plus 5 equals 2. Take away 5 from both sides. I'm running out of room, so I'm not going to write it, but it's 9a plus 3b, and then we'll take away 5 from both sides, giving us a negative 3 over here. All right, so now at this point, what we want to do is we have what we have right here is we have this equation and we have this equation. And we need to try to find out what a and b are. So we've got a system of 2 variables. We need to find out what both of those 2 variables are. What we need to wind up doing is solving our system here. And we solve our system by either elimination or substitution. I'm going to pause the video so I can hear the guy waxing the floor coming back. I think this video gets an award for most interruptions, so I apologize for that. Alright, so when we left off, we were talking about we have now 2 systems, or we have 2 equations. We're going to solve it by elimination, because that's usually one of the quicker ways to do it in this case. So I'm just going to go ahead and rewrite it. We know that we have 4a plus 2b equals negative 4, and we have 9a plus 3b equals negative 3. So we need to eliminate it. I would suggest, although it's not the only way to do it, I would suggest eliminating the b's. And to do that, you would have to multiply this one. Their common factor between 2 and 3 would be 6. So we want one to be a 6 and one to be a negative 6. So we could multiply this one by positive 3, and then we could multiply this one by negative 2, and that's going to create a system which would allow some cancellation or some elimination to happen. So 3 times 4a, that's 12a, and then 3 times 2b, that's 6b, equals 3 times negative 4, that's negative 12. Negative 2 times 9a, that's negative 18a, plus negative 2 times 3b would be a negative 6b, equals negative 2 times negative 3, that's a positive 6. Alright, so now we're going to add, and the b's cancel out. A negative 12, or a 12a and a negative 18a would give me a negative 6a equals, the b's cancel, and then we have a negative 12 and a positive 6, which would be a negative 6. Divide by negative 6, and we get a is negative 6 divided by negative 6 is positive 1. Alright, now we have our second part. We have our a. We know c already from over here. Now we just need to plug in and get b. So we're going to take either one of these equations, plug in, and get b. So now that we know that a is 1, we're going to say that we have 4 times 1 plus 2 times b equals negative 4. I just used this one right here. 4 times 1 is 4, so 4 plus 2b equals negative 4. We're going to subtract 4 from both sides. Oh, I messed up. So now we have 2b equals negative 8. Divide by 2, you get b equals negative 4. Alright, so now we know our a, our b, and our c. Now we can finally write this system. It would be, and I'm going to go ahead and move this off to the side. I'll do it in a different color here. It's going to be 1 times x squared, which we don't usually write the 1, so just x squared. And then b is negative 4, so minus 4 times x, and then c is positive 5, so plus 5. And that is what f of x is. Alright, so why don't you guys tell me this one? It's going to be fill in the blank. I need to know what a, b, and c are. And then write your function. And then today in class we'll talk about how we can do this with our calculators. Alright, we'll see you then. Sorry about all the interruptions.